Hello, lovely algebra students. The lesson you're looking at today is how you solve systems of equations using graphing. I want to pause for a second and have you ask yourself, what do you remember about the previous lesson on solution points? There was two main things we had talked about with solution points. So I'll pause and give you a chance to ask yourself, what do you remember? Okay. The part you're probably thinking about was that idea of a solution point as a point that satisfies the equation. That was the part of that definition we used a lot in that first lesson, meaning if you wanted to check to see if a point was a solution point, you check to see, does it satisfy the equation? When you substitute it into the equation, does it give you something that's true? The second part, though, of what solution points are is that part that said a solution point is a point that lies on the line. So we had said in the first lesson, if you have a single line, there are lots of solution points because there are lots of points that lie on a single line. We use the word, there are infinitely many solution points for a single line. But at the end of that first video, I said when you're talking about a system of equations, which is two equations, when you're looking at a system of equations or two equations, that means you have two different lines. The idea of a solution point's the same. It's a point that satisfies the two lines and lies on both lines. But when you talk about solution points for systems, there's only that one solution point there. So we had kind of left it at that with the first lesson. What this lesson is about, though, is how you actually find that solution point. Not just checking to see is it a solution point or not, but actually finding that one point. You look at that first example, the one that says y equals 2x minus 1 and y equals x plus 2. If you're given a system like this, you can actually find the solution point by using that second part of the definition, meaning a solution point is a point that lies on both of these lines. You can find that point by literally graphing both of these lines and finding where those lines intersect. That intersection point is going to be the point that lies on both lines. Now, it's hard for me to graph since I don't have graph paper, but when you go to graph it, it would look something like a line starting at -1 and going up 2/1. So a line that looks something like this. And then another line starting at a +2 and only going up 1/1, so looking kind of like this. And then you find that solution point is that point where they intersect, which would be the point 3, 5. 3, 5, if you were to check to see if it satisfies the equations, it would be able to satisfy both of them. If you substitute 3, 5 for this first equation, you get 5 equals 2 times 3 minus 1. So 5 equals 6 minus 1. 6 minus 1 is 5. So that works out. And if you were to check it in the second equation, it would say 5 equals 3 plus 2. Well, 3 plus 2 is 5, so that also checks out. There are going to be a couple different ways we solve systems, but we're starting off with solving by graphing because you are already really familiar with how you graph lines. And it's just this idea of the solution point is going to be that point where those two lines intersect. So if I give you any sort of system and I ask you to solve it by graphing, the main idea is graph both lines, find where that point is those two lines intersect, and that'll be the point that's your solution point. It'll also be the point that satisfies both equations. It'll be the only point that satisfies both equations in this scenario. Now, the other part that I wanted to talk about while I have you is on the third page. It's under the heading Type of Solutions. When you go to graph some of these systems of equations, you're going to see a lot of systems look like that one I just graphed. Not exactly like it, but similar in the sense that you'll have two lines that intersect in one location, and that one location is going to be your one solution point. So oftentimes we'll have two lines that intersect at one point, and that one point is your one solution point. And if you have one solution point, we're going to label it with an x and y coordinate like we did in that first example. That, however, is not going to be the only option. So if you think about some of the lines in the past we've graphed, when we've graphed two lines simultaneously, sometimes they would intersect like this, but that wasn't always the case. You can also have two lines that look like this. What type of lines are those? Hopefully you are saying the word parallel. What do we know about parallel lines? Well, we've learned they have the same slope, but more importantly here, we've learned parallel lines don't intersect. So when we've talked about how solution points for systems are that point where those lines intersect, if you have two lines that don't intersect, where's the solution point going to be? Well, there isn't going to be any point that lies on both lines. If you think about this point, this doesn't lie on both lines. This point here doesn't lie on both lines. There's no point I can choose that's on both of these because they don't intersect. Therefore, if we get a system that graphs with parallel lines, we would have to say there is no solution. There is no solution because these lines don't intersect, so there's literally no solution point on both lines. There's no point that would satisfy both equations. That is our second scenario. Now our last one, which is the one that's in the middle on your graph, is what if you went to go graph your two lines? You graph your first line, and it's right here, and then you go to graph your second line, and it's in the exact same spot. So I'm going to draw it like that with arrows to kind of show there's two lines on the same place in the graph. We've been saying solution points are these points where the lines intersect. So here there was one solution point where those lines intersected. So there's one solution point for our answer. Here there's no point where those lines intersect. So there's no solution point. That's our final answer. If you have two lines on top of each other, how many points are on both lines? None? One? There's actually a lot. Any point you pick on one line is going to be on the other line because they're in the same place. So we can't label a single point like this because there's a lot of different points. In fact, instead of saying a lot of different points, you've learned a word for it. There are infinitely many. So for this middle one here, we say there are infinitely many solutions. Infinitely many solutions because there are infinitely many points on both lines. So there are infinitely many points that would satisfy both equations. These are our three options we have when we talk about solving systems. If you solve a system, like those first couple examples in the notes where you find one intersection point, your answer is going to be that one point. Just go ahead and label it. But if you get two lines that are parallel, we would have to say no solution because there's no intersection point. And if you get two lines in the same place, you would have to say there are infinitely many solutions because there are infinitely many points on both lines. This is what we mean when we talk about types of solutions. All systems are going to fall into one of these three categories. Those are the two main things I wanted to talk about for these notes. I wish you the best of luck. You guys did really awesome on the first lesson all by yourself. I know you missed class. I miss you all too, but we'll get through this, and you guys are doing great. Just keep up with it. Bye.